I'm about to engage, encircle, and inform. We have epic information for your mind. Wake up wherever you may be. Turn on all the lights. The hour has come. You are definitely tuned in to the Watcher's Prophecy News. Greetings, my name is Mars. I am host tonight of the WPN, only on www.kdov.us. KDOV Radio is America's premier radio station, serving inquiring Christian minds who are definitely not asleep. Tonight I have a very interesting subject to ponder, and you may have to actually put on your thinking cap, sure. See, tonight we travel into a very strange direction, a place where few believe we should even go. Most folks today would not think of such things, but gather around because the bump you feel just might be strange creatures just beneath the thin veil of dimensional awareness. The clock ticks every second, and every second that passes has elapsed. It went somewhere. Where did it go? Is that second that passed really gone? And if actions that occurred in that second could be taken back, would you dare to do such? How many of you have ever heard or had deja vu? What do you think of it? What do you think it means? Is it just the pineal gland, the third eye, that allows you to see into the future or beyond? Knowing in some instant a feeling so profound that you have been there before, but have never yet been there. Is that in itself some type of time travel? Or is there more? On KDOV Radio tonight, the WPN will explore this and more. You know, some people say time flies. Some people say time is money. We waste time, we kill time, we try to save time. But what do we really know about time? Many of us grew up with Doctor Who, the Time Bandit, or watching glossy DeLoreans travel back in time. And as a great science fiction fan myself, I first encountered time travel ideas in 6th grade as soon as I picked up H.G. Wells' book on the time machine. But in this age of advanced technology, we already are on the verge of major breakthroughs in time. Advances in CERN have now shown us that these things are not just probable, but they are indeed possible. We're just now advancing into Newton's fifth steep of technology. What will the future hold? One day, it may be common to go to work in the past to get paid in the future. Or can we go back and change the mistakes we have made in our own lives? God said we live once, and then we have an appointed time to die. As soon as in little as 60 years, at the current rate our technology is doubling, the reality of time travel may be but just a simple call away to Amazon.com to order your fourth dimensional time travel kit. Personally, the idea of time travel is mind-blowing, and we can only imagine for now, but as our technology grows, time also grows short. For we know soon our Lord will stop us before we grasp angelic, demonic technology that we know, like our current nuclear weapons, for mankind could only lead to dilemma after enigma unimaginable. Now, ladies and gentlemen, I am not going to rob you of your time tonight, but I appreciate you turning in to KDOV Radio. See, time could be like this river, way people most see it. Time seems to flow endlessly from one moment to the next. And the flow of time seems to always be in one direction, that's toward the future. But that may not be right. See, discoveries over the past century have shown that much of what we think about time may be nothing more than an illusion. Contrary to everyday experience, time may not flow at all. Our past may not be gone, and our future may already exist. It seems this fusion of time and space would lead Einstein, other notable scientists, to perhaps the most mind-bending realizations of all. The very sharp difference we see between past, present, and future, as I said, may just be an illusion. You can ponder that for a moment. Thinking about space-time like this led Einstein to overturn our everyday pictures of the past, the present, and the future. Science has a habit of asking stupid questions. I may be among them, because time travel has always been very fascinating to me. Stupid, that is, by the standards of common sense. I know my grandmother would say, "You're wasting your time." But time and time again, we have found that common sense is a very poor guide to what really goes on in our world. So if your response to the question is, why does time always go forward, not backwards? Is that it is a daft thing to ask? Just be patient. Surely we have time for that. Surely we can just say that the future does not affect the past, because duh, it hasn't happened yet. Not really. For the question of where time's arrow comes from is more subtle and complicated than it seems. What's more, that statement might not even be true. Some scientists and philosophers think the future might indeed affect the past, although we could only find out when the future arrives. And it may be able to due to a emergent property of quantum mechanics they are now discovering at CERN. I'm telling you, things are not as they seem. First of all, it may be that you can build a time machine to go out into the future, but not into the past. And we don't know about it because we haven't yet invented that time machine. Secondly, it might be that time travel into the past is possible, but they haven't gotten to our time yet. So they're very far in the future, and the further back in time you go, the more expensive it is. Maybe their meter ran out. Thirdly, maybe backwards time travel is possible, but only up to the moment that time travel is invented. We haven't invented it yet, so they can't come to us. They can come to as far back as whatever it would be, say, AD 2300, but then not further back in time. We don't know. But we are learning. Then there is the possibility that they're here all right, but we just don't see them. They have some perfect invisibility cloaks or something. If they have such highly developed technology, then why not? Then there's the possibility that they're here and we do see them, but we call them something else. UFOs or ghosts or hobgoblins or fairies or maybe something dark in your closet late at night. Finally, there's the possibility that time travel is perfectly possible, but it requires a great science in our technology, and human civilization will destroy itself before time travelers invent it. That is the most likely scenario with us. or warlike race. I'm sure that other possibilities exist as well. But if you think about those things for a moment, it will take even more of your precious time. See, the fact is that everything that you do in your life has a price. And that is the amount of time of your life that you spend on it and for it. Ever since St. Augustine, people have wrestled with this. And there are all sorts of things that it isn't. It isn't a flow of something, because what does it flow past? We can't even determine that. We use time to measure flow. How could we use time to measure time? We seem to be stuck in it. Each of us time travels into the future, 1 year, 1 day, 1 hour, 1 second. None of us, to any significant precision, does anything otherwise. If we could travel close to the speed of light, then we could travel further into the future in a given amount of time. It is one of those concepts that is profoundly resistant to simple definition. It might be that you can build a time machine to go into the future, but not into the past. You think that backwards time travel will ever be possible? It just might be, however, now that CERN has discovered new particles that have no mass that do exactly that. And we are learning from them every day. You see, for most people, such questions are purely a matter of evidence. Show me. And if the evidence is inconsistent or insufficient, then we withhold judgment until there is better evidence. Right now, we're in one of those classic, wonderfully evaluate moments in science when we just don't know. When there are those on both sides of the debate, and what is at stake is a very mystifying and very profound arguments that things may not be as they seem, even right now before you. Now, if we could travel into the past, it's mind-boggling that we would definitely see things that have already occurred. And for one thing, history would become an experimental science, which would certainly make it different than it is today. History books would have to be rewritten. Many lies would be overturned. Many things done that were sins and regrets in your life may be possible to just simply be erased without a prayer, because you were able to go back and change those things. Possible insights into our own past and the nature and origins would be dazzling. For another, we would be facing the deep paradoxes of interfering with the scheme of causality that has led to our own time and our own selves. I have no idea whether it's possible or not, but I am told by the very best and brightest that it is definitely possible and worth exploring. Time machines are commonly seen in every kind of science fiction film, from Star Trek to Doctor Who, as I said. But as of yet, no one seems to know how to build one. Of course, here at the Watcher's Prophecy News, we are working hard on that. It is possible to slow down time by traveling very fast relative to someone who is stationary. That we know is true. This was predicted by Einstein's theory of relativity at the beginning of the 20th century and has been proven many, many times. One of the best examples of this was demonstrated by putting a very accurate clock on board a passenger jet, a 747. Another identical clock was kept on the ground and synchronized with the clock on the airplane. After a number of long-distance flights, the two clocks were compared, and the one that had been on the plane was running behind the clock that stayed on the ground. Whoa, somebody's wrong. The difference between the two clocks was exactly the difference predicted by the theory of relativity. It is important to understand that this slowing down of time depends on the speed you are traveling at relative to someone else. None of the passengers on the plane would have noticed anything strange. They never do. I never have. As far as they are concerned, time is passing as usual. It is only when they get off the plane and compare their watches with someone who has been stationary relative to them that they notice any kind of difference. You see, passenger jets only fly at about 600 miles an hour, which seems pretty fast. However, after the experiment describes the difference in time between the two clocks was less than a billionth of a second. That is why very accurate clocks are needed. Now, if you could travel at speeds close to the speed of light, about 186,000 miles a second, that's very fast, time would slow down beyond belief, very significantly, from the perspective of someone who is not moving. So if we were to venture out to another star at that speed and measure those clocks against someone on the ground who is not moving at that speed, time would definitely be moving. There are many problems and obstacles, however, that must be overcome in order to make a time machine, or to even understand the complex theories behind it in order to establish something that would work. You see, most people don't want to go back in time. Most people don't want to go forward in time. Most people don't even ponder what time is, but they definitely like to save time whenever they can. There are many paradoxes in time travel. There is a paradox called the grandfather paradox, and it is a paradox of time travel in which inconsistencies emerge through changing the past. This name comes from the paradox common description as a person who travels to the past and kills their own grandfather, preventing the existence of their father or mother and therefore their own existence. Any inconsistency in past events may be regarded as the grandfather paradox. Even without knowing whether time travel to the past is physically possible, the grandfather paradox can be explored from a very logical perspective. The paradox is a logical contradiction that stems from changing the past, or the present, or the future, from the way that it is. If an event has occurred one way, there is no possibility for the event to have occurred in a different way. Then logically, changing the past, or the present, or the future, from what it is, results in a contradiction, which means changing the past could be impossible. But there are many physicists who will now disagree because subatomic particle physics are beginning to show us that these things are not even as we could imagine them. Still exists the logical possibility of traveling back in time and setting events into a new way, the way they are. For example, a time traveler intending to kill their own grandfather, but instead killing someone who is not their grandfather. See, consideration of the grandfather paradox has led some to the idea that time travel is by its very nature paradoxical and therefore logically impossible. For example, the philosopher Brandon Downen made this sort of argument in a textbook, Logical Reasoning, where he wrote this: "No one has ever built a time machine that could take a person back to an earlier time. Nobody should be seriously trying to build one either." Oh, goodness. That definitely jinxes me. "Because a good argument exists for why the machine can never be built," he states. The argument goes like this: suppose you did have a time machine right now, and you could step in it and travel back to some earlier time. Your actions in that time might then prevent your grandparents from ever having met one another. This would cause you to not be born and thus not step into the time machine. So the claim that there could be a time machine itself is in fact contradictory. However, as we explore this deeper, some philosophers and scientists believe that time travel into the past need not be logically impossible, provided that there is no possibility of changing the past, as suggested, for example, by the Nikolov self-consistency principle. We'll explore that. That is a big name and deserves a little attention. Now, Brandon Downen himself revised the view above after being convinced of this in exchange with another philosopher, Norman Schwartz. So we're going to get into this Nikolov self-consistency principle and explain this a little bit. This is getting deep. Now, many of you will have to understand that the Nikolov self-consistency principle is very deep. It expresses one view on how backwards time travel could be possible without the danger of these grandfather paradoxes. According to his hypothesis, physics in or near closed time-like curves, a time machine, can only be consistent with the universal laws of physics, and thus only self-consistent events can occur. Anything a time traveler does in the past must have been part of history all along. Therefore, time travelers may be changing things, and we do not even know about it. Think about that. For all intents and purposes, time seems to have a direction. When we look at our watch, that hand always moves in one direction. Even digital watchers count upwards. Our everyday experiences insist that only things happen one way. Cups of coffee always get colder. They never get warmer. When left to stand, they are knocked on the floor, the cup becomes shards, and the coffee goes everywhere. But shards and splashes never spontaneously reassemble into a cup of coffee. Can't go back. Something, indeed, is fishy. Yet none of this one-way flow of time is apparent when you look at the fundamental laws of physics. The laws, they say, that describe how atoms bounce off each other, very deep indeed. So we're not going to get so incredibly deep that you have to have a degree to hear this show. But these laws of motion make very little distinction about the direction of time. If you watched a video, for example, of two billiard balls colliding and bouncing away, you would be unable to tell if it was being run forwards or backwards. This same time symmetry is found in the equations of quantum mechanics, which govern the very behavior of very tiny things like atoms that you, indeed, are made of. So where does time's arrow come from, and how how did we figure that out? How come our watches don't run backwards? How do we have an understanding of which direction time's arrow goes, and how did it get there? Now, there is a long-standing answer to this, which says that the arrow only enters once you start thinking about lots and lots of particles, not just a few. Molecules are likely to get mixed up. The process of two atoms colliding looks perfectly reversible, just as the billiard balls. But if there are lots and lots of atoms, their interactions lead inevitably to increase in randomness. Simply put, because that is by far the most likely thing to happen. Let's explain that in more layman terms. Say if you have a glass of nitrogen molecules in one half of a box and oxygen molecules in the other half of a box, and they're separated by a simple cardboard partition. If you suddenly jerked away the partition, the random movements of the molecules will quickly mix the two gases completely. They'll mix up all by themselves. There is nothing in the laws of physics to prevent the reverse. Nothing. A mixture of the two gases could spontaneously separate right back into oxygen in one half and right back into nitrogen in the other half just by chance. There's nothing that says that they cannot. But this is never likely to happen in practice because the chance of those billions of molecules just happening to move this way in concert is very tiny. You'd have to wait for longer than the age of the universe for such spontaneous separation to occur once you remove the cardboard. The inexplorable growth of randomness is enshrined in the second law of thermodynamics. The amount of randomness is measured by a quantity called entropy. And the second law states that any process, the total entropy of the universe always increases. Of course, we can decrease the entropy of a group of molecules, say by sorting them one from another, but doing that work inevitably releases heat, which carries even more disorder, more entropy somewhere else. Ordinarily, there is no getting around these types of equations. Does that mean that we can't have time travel? Does that mean that this is also complicated, that I just can't figure out how we could possibly ever build this time machine? Well, that is not true. Scientists, believe it or not, there is a project currently going on, a side project of CERN, to actually do just that. Scientists are now working on a very secret project, and the project is so classified that the amount of information that I've been able to glean about it is very small. Doesn't even have a code name that we've been able to come up with. That's odd all by itself. But there are about 12 scientists that are working to actually build a time machine. That's right. And if they succeed, things are going to get very sloppy. The anthropic arrow of time gets less well defined at smaller scales. For example, the chances of 3 oxygen and 2 nitrogen molecules briefly unmixing are actually pretty good. This was illustrated in a 2015 study by using this very same experiment that we just detailed. Researchers studying a single molecule found evidence that when the growth of entropy is a good measure of how far the system was from being reversible in time. This argument about entropy, which has worked out in the late 19th century by Austrian scientist Ludwig Boltzmann, is often seen as a complete and satisfying answer to the puzzle of time's arrow. It is very deep and complicated, so I'm going to try to break it down and explain a little bit of it. It turns out that the universe holds many deeper secrets, but when you start looking at very small things, Boltzmann's neat story gets amazingly muddled. It's not quite as it seems. In Boltzmann's picture, it takes a while for the arrow of time to find direction. In the tiniest fractions of micro nanoseconds, that must be incredibly small fractions, of a second after the partition between the two gases is removed, before any of the molecules have really moved anywhere, there is nothing to show which direction of time is forward. Entropy increases when collisions between the atoms even out their energies, as for an example, when the heat of hot coffee spreads out into the surrounding air. This process, which washes away reservoirs of energy, is called dissipation. Until dissipation starts to happen, a process looks much the same backwards or forwards in time. It really does not have a thermodynamic arrow. But there is a one-way process in quantum mechanics that happens much faster. It's called decoherence. Now, we're going to get to an experiment so that I can explain this, and you're definitely going to have to expand your mind around some of what I am about to show you. It's called the double slit experiment. Now, at the quantum scale, particles behave as if they are waves. This alone has particular consequences. For example, if you shoot individual electrons or whole atoms through two closely spaced slits in a screen, they will interfere with each other as if they were waves. But this does not happen with ordinary sized objects. If you threw two coffee cups through two open windows, they do not interfere with each other. But decoherence explains why objects on the everyday scale of coffee cups do not show the wave-like behavior of quantum objects. It arises because quantum particles can be coordinated in their quantum waviness, but if there's lots of them, like countless atoms in a coffee cup, they rapidly lose any coordination. This means the object they constitute cannot show quantum behavior. That means as a human, even though you are made up of quantum particles, you by yourself don't show quantum behavior. Decoherence happens because the interactions between the objects and their environment, for example, the impact of air molecules on the cup. Quantum theory shows us that these interactions rapidly cause a large object's quantumness to link into its environment. This means the object takes on unique characteristics. Quantum theory tells us that these objects can show one of many possible properties when they are measured. But in our everyday world, objects only have a single well-defined position, speed, and so on. So decoherence is thought of how this choice is indeed enforced. And all that may have sounded like a bunch of gobbledygook, but to the folks that are working on the time machine, this is indeed a thing that they are dealing with. There are colliding particles everywhere, so quantum decoherence is incredibly fast because interactions between particles are extremely efficient at dispensing quantum coherence. Let me give you an example. Try to break everything down so that everyone can understand this. Not everyone is into the more tricky physics, but when you hear this show and you understand after I'm done all of these things, how they apply, you'll understand the vast task at hand for scientists to build such a thing. And they are indeed working on it. In fact, from what I've been able to glean, they have technological devices they are currently working on. That means they've gone out of the realm of theory. That means they're no longer just discussing this on paper, but they're building something. Really? See a dust grain, just a grain of dust, 1,000th of a centimeter across, floating in the air. The collisions of other air molecules will destroy any quantum behavior in less than a half of a nanosecond. That is a trillionth of a time that it takes light to cross the face of a single hydrogen atom. This is much faster than the time that it takes for the heat in the dust grain to get redistributed into the environment. In other words, decoherence is faster than dissipation, and it seems to only work one way. That means decoherence reveals the arrow of time faster than dissipation. So the key to time travel must be in decoherence some kind of way. This implies that the arrow of time actually comes from quantum mechanics, not thermodynamics, as Boseman first thought. So in reality, the scientists that are working on this have come to the conclusion that in both the classical and quantum cases, that time's arrow indeed comes from the loss of information or entropy itself. It really makes you look down at your watch and watch the second hand, but I'm about to offer you a better way to think of time's arrow. It points in the direction in which information is lost. It can never be retrieved. This process is truly irreversible when the information about the change is lost, so you cannot retrace your steps. If you could keep track of the movements of every single particle, in principle, you could reverse it and get back to exactly where you started. But once you have lost some of the information, there is no return. The loss of information is the key aspect. Entropy, says Dr. Ellis. I'm going to get deeply into him in a moment. Want you to understand, I am going to break this down very simply. At the microscopic scale, this is why quantum computing is so very important to the United States government and to this very secret project. He stated that scientists there needed to record things that simply slip away through time itself so they can be reassembled, and this gives us our clue on how to build the time machine itself. It is still not entirely clear when, in the quantum world, the information is truly lost. Some researchers think that decoherence alone is enough, but others say that the information, although smeared and dispersed in the environment, is still recoverable some kind of way. They think in additional, rather mysterious process called the collapse of the wave function, in which the quantum waviness is irreversibly lost, takes place. Only then, they say, does the arrow of time ambiguously point in one direction. In either case, In quantum physics, we can only really say that an event has happened if we have lost the option of making it unhappen. As complicated as that may seem, the arrow of time seems to reflect a process of the universe committing itself to something, rather than hedging its bets by allowing for many different outcomes. In this crystallization of the classical present from the quantum past, says Dr. Ellis, that produces a singular direction in time. Now, I spoke with Dr. Ellis on the telephone. He wanted to remain a bit ambiguous, but folks can definitely question me upon this phone call. He is a former MIT physics teacher who now works with CERN data and is writing a book on time travel here in Boston, United States of America. He tells me that what I've always known, things that my father taught me about crime and hidden things, is to follow the money. So and such, he has told me that some $1 trillion, that's just unimaginable amount of money, folks. If you just knew how much a trillion is, most people can't even count to a million, let alone a trillion, from the United States has secretly been put into this one CERN experiment and many others like it that deal only with the problems of time travel, as they, the elites, seem to want this time machine to escape something they know that is hiding just around the corner in time. Now, I said, how do you know all this? He told me that there is many trillions of Pentagon dollars missing in actions that work, and key spies that have toed upon the doings of many CERN things, currently being linked out to the press now even. But several key physicists have been giving great amounts of money to work and are building this machine right outside of CERN in a secret place, so secret in fact that folks have already been killed to keep it secret. Told me that much of what he knew was going in this soon-to-be published book so that I could not have it all, but that those who wanted such a time machine built were dead set upon having it and were so determined that nothing would stop them. They wanted to escape something. Now, folks, that alone should tell you a great deal about what is about to happen in our world. Time travel, he says, is such a key part of their escapism thinking that their bunkers alone are not enough to save them from whatever they fear is around the corner, so to speak. So more has to be done, more money, more time, to figure out the very fine ideas of time travel and what those things exactly were. Some of those things they are working on, I am attempting to explain here tonight on the Watcher's Prophecy News. Appreciate everyone coming tonight on KW Radio. There is more. Now, there are ideas that fit in very neatly with what we discussed earlier about the direction of time. Some are very famous thought experiments in physics. Why do certain effects come after their causes? Second law of thermodynamics say that things tend to become more random, but only because randomness is so likely. In the late 19th century, the Scottish physicist James Clerk Maxwell come up with what looked like a way to get around this. Maxwell imagined a tiny, intelligent being that could observe the random motion of molecules. This little man could unmix the two gases by opening and closing the door just at the right moments. But Maxwell's little man seemed to violate the second law, but in fact it cannot. The reason is that the little man had to accumulate information in its brain as it observes the molecular motions. To keep this up, he has to delete the older information, as anyone's brain only holds so much information, even the human mind. We can actually overload our own brain. That can happen. And that increases the entropy. It is the act of this erasure or forgetting that guarantees the thermodynamic arrow of time. Once again, the key thing is loss of information. However, the quantum mechanical picture of time's arrow leads to something deeply peculiar. Some experiments, it looks as though the influence can work backwards in time. The future can indeed, now they are saying, affect the past. Now think about that. The future can deeply affect the past. Really? Now, let's take one of the experiments called the double slit experiment that we discussed earlier, which a quantum particle such as a photon of light is fired at two narrow slits in a screen. Suppose we do not measure which way the particle went and so cannot tell in which slit that it went through. In this case, we see what is called an interference pattern, a series of light and dark bands. It looks like a wave when the particles emerge on the far side. This reflects the wave-like character of quantum particles because interference is a wave property. The interference even persists when the particles pass through the slits one at a time, which only makes sense intuitively if we imagine each particle passing wave-like through both slits at once. However, now suppose we place a detector, something that can observe, by the slits to reveal which one of the particles pass through. In the case, the interference pattern disappears and the particles act more like sand grains being fired through holes. Measuring a particle's path destroys its waviness. There is the reality of other strange things. We can set up the experiment so that we can detect which slit a particle passed through after it has done so, and yet we will see still no interference. How does the particle know that it's going to be detected after passing through the screen? So that when it reaches the slits, it knows whether to go through both slits or just one. How can the later measurement seem to affect the earlier noticed behavior? This effect is called retrocausality, and it seems to imply that the arrow of time is not strictly one way as it seems, but does it really? Because these scientists are working very hard on a way that might very much destroy your own reality. Now, I want you to think about that. Would God even allow such? Must time only flow in one direction? Now, most physicists think that retrocausality in these delayed choice experiments is an illusion created by the counterintuitive nature of quantum mechanics. Detecting a particle after it has passed through the slits does not really influence the path it takes, they say. That is just the way we are forced to imagine what is happening when we try to apply our classical intuition into quantum events. Post-selection is like a parlor trick that makes it seem like there is backwards causation where actually there is none. Now, Dr. Ellis says that it is like a guy who shoots at the side of a barn and then goes draw a target around the bullet hole. However, others say that backward effects in time are a perfectly valid way of interpreting. See, I'm getting mixed up in time. Such processes. Dr. Ellis was nice to explain all of the ins and outs to me, some of which was extremely puzzling. But we can regard retrocausality as a kind of fuzziness in the crystallization of the present. Quantum physics appears to allow some degree of influence of the present on the past. As indicated by the delayed choice experiments, he says, Dr. Ellis has then argued to me that the past is not always defined at any instant. It is like a block of ice that contains little blobs of water that have not yet crystallized. Even though the broad outline of the events in a particular instant may have been decided, some of the fine details remain fluid until a later time. Then when this fixing of the details happen, it looks like they have retroperspective consequences. It is hard to find the right words to describe this particular situation, he said. Certainly, we should not imagine a force reaching back through time and altering earlier events. Instead, those things are slow to acquire the true status of events, stuff that has actually happened at all. Alternatively, perhaps, those past events really did happen at the time, but the laws of quantum mechanics forbid us from seeing them until later. If the future detector choice causes the particle to behave a certain way in the past, one should consider the past behavior real when it originally happened. Quantum retrocausality crops up quite naturally if, instead of trying to force an arrow of time into a quantum theory, we simply let quantum mechanics work equally well in both directions in time. This is why they believe they can build this machine. Now, what they've built so far, we don't know. We don't even know why they're trying to escape, but it must be something very awful to them. Maybe it's their own sins. Maybe it's the fact that they can't come to God for forgiveness. They're too scared. They're still hiding in the darkness. We do not know, but we do know that the very signs, the very symbols on the outside of CERN certainly make it look like a very dark place in their own minds. Only a handful of physicists and philosophers have actually embraced retrocausality. Most consider backwards causality too high of a price to swallow. Dr. Ellis feels that we only resist this idea because we're not used to seeing it in daily life. Anything that we don't see or don't notice just happened a few moments ago. We can't get it back. We can't get it back because pieces were lost that we did not save. They are attempting now to save those very pieces. In view that the past does not depend upon the future is largely a misconception, we should take apparent backwards causation more seriously than we usually do. Our intuition has usually been wrong. This time, symmetry on quantum scales is a reason to think that we could be wrong again. If time's arrow is not quite as one way as it seems, that raises one last question. Why do we perceive it as always pointing one way? Why should the psychological arrow of time be aligned with physical ones? There are many things that we do not know. Again, it may sound like a very odd question. If the laws of physics dictate the arrow of time, surely our perception of it should quite follow naturally, but it is not as obvious as it sounds. Suppose you have some particles moving around in a box according to physical laws. If you know all the exact positions and speeds of the particles right now, you can predict the future exactly. That's true. In principle, there is nothing in the future that cannot be known in the present. Why could that not be experienced as a memory of the future? And does it explain our own little things that we call deja vu? Has God given us this third eye for a reason? A little like a master chess player seeing well in advance how the game will inevitably end. This question is usually swept under the carpet since biology rests on a foundation of chemistry, which rests in turn on foundations of quantum mechanics and thermodynamics. I think that most people believe that the biological arrow of time is a consequence of the thermodynamic arrow. But it is not a foregone conclusion. And many argue that the psychological and thermodynamic arrow of time are actually independent. They only coincide because of how our own brains work. Now, there are many things in this life that we do not know. We know that the things that we are not supposed to know are likely written in the Word of God, and God has told us that the life that we have lived and the things that we have done will be judged one day. Now, we only get one life, that we shouldn't be going back in time to live over and over again. Doesn't say that anywhere in my Bible. But I thoroughly believe that these people believe that they can outdo this, and they are spending trillions of dollars doing it. You have to understand that in physics, many things are not as simple to explain as one would like to understand them. And we have to ask, what does all this mean? It means how we choose to measure now affects what direction that photon took billions of years ago from some distant star to get here. Our choice in the present moment affected what already happened in the past. Makes absolutely no sense, which is a common phenomena when it comes to many quantum physics things. Regardless of our ability to make sense of it, it is real. And if we can't measure it, many believe that how would we know, and does it really exist? Ladies and gentlemen, there are ones that are attempting to escape. And they want to escape something that's coming that is very, very bad. Now, I don't know what this thing is, but I bet you money it's written on the pages of my Bible. Maybe they feel that they need to escape the coming Gog War. I don't know. But I do know this, that time continues to tick. And we are advancing into the Great Tribulation. This has been Mars for the Watcher's Prophecy News. Come join us next week as we get into more conspiracy radio. Thank you for listening to KDUV. Good night.